Dear students, I welcome you back to the multiple integrals chapter. So, this is the sixth session. We are going to discuss about some problems on application of triple integrals and then beta and gamma functions. So, in the last session, we had a discussion about how to evaluate the triple integrals. I told you that there are six possibilities of evaluating the triple integrals, which are listed here. Type 1, mainly the z variable is integrated with respect to z. The variable z limits are functions of x, y. So, that is integrate first with respect to z, then the other two variables are x and y or y and x, that is type 1. In the type 2, first you integrate with respect to x when x limits are functions of y, z, then go for z and y or y and z. Then the third type we discussed, first integration with respect to y means the y variables are functions of x and z here, then integrate with respect to x, then z or z with respect z and then x. So, these were the, for any surface is given, you have to identify the limits which type you want, type 1 or type 2 or type 3 from the given f x y z. Given the solid, E is the solid, it is given in the problem. From the solid, how you take the limits of type 1 or type 2 or type 3. So, that was discussed in the last session. Now, we will move to the applications of triple integrals. Just to recall, what about the single integral? If f x y is a positive function, I told you earlier, then the single integral a to b f x dy, this represents the area under the curve y equal to f x from the two ordinates x equal to a and x equal to b. This we studied. The single integral geometrically represents the area under the curve between two ordinates above the x axis. In the similar manner, for the function of two variables, if f x y is positive greater than or equal to 0, then the double integral represents f x y dx dy over the region R. R is in the xy plane. This represents the volume under the surface and above the region R. So, this is the representation of the double integrals. Then move to the triple integrals. What is the representation of the triple integral? When the function f x y z is positive, f x y z is positive, the triple integration representation is, it is not very useful here. When f x y z is greater than or equal to 0, how the double integral represents volume and single integral represents area. What about the triple integral represents? So, it would be a 4-dimensional object. So, in the single integral, that was area is a 2-dimensional, double integral, the volume 3-dimensional. So, similar way, the triple integral, it would be a hypervolume, we call it as, it is not the volume, hypervolume, it is a 4-dimensional object. So, this integral is not so useful here. Of course, this is very difficult to visualize. We have visualized the single integral under the area under the curve, and similar way, the double integral represents the volume, that also visualized in 3-dimensional, but it is very difficult to visualize the 4-dimensional object. Remember that E, that is the solid region, just the domain of the function f of x y z, the graph of f lies in the 4D space. So, how f x y lies in 3D space and f x lies in 2D space, similar way f x y z which lies in the 4-dimensional space. So, it is very difficult to visualize. Now, moving to the applications of triple integrals. This can be interpreted in different ways in different situations. This depends on the physical interpretations of the variables x, y, z and also the function f x, y, z. So, here if f x, y, z is 1 for all the points in the region E, that is the solid region, then the triple integral represent the volume here. When f x, y, z is 1, the triple integral 1 into dx, dy, dz, it does represents the volume. And if that is 1, see how the triple integral reduced to f x y z is 1 in the formula. So, the inner integral is z with respect to z, its limits are functions of x and y. So, when f x y z is 1, simply the integration of dz is z. So, z replaced by upper limit and lower limit, you will get the difference between the functions of x y. These two are what? u1 and u2 are the surfaces in 3-dimensional. So, this represents the volume that lies between these two surfaces. So, it is exactly the double integration evaluation. D is the region in the 2-dimensional space. So, when f x y z is 1, after the integration with respect to z, that becomes the double integral problem, it is the volume problem. So, this represents the volume between two surfaces, one u2 and one u1. Then note that it is not necessary to use the triple integrals to compute the volumes, because we discussed many examples to compute the volumes using double integrals, not the triple integrals, because they simply give an alternative method for setting up the calculations. In the previous slide, f x y z is 1, it gives the volume just as alternative method for setting up the calculations, and also the all applications of double integrals can immediately extended to triple integral. Whatever the applications we studied, mass, center of gravity, all those you can extend it to triple integral also. So, one of the application we discuss, if rho it is a function of x y z, is a density function of the solid object that occupies a certain region E at any given point x y z, then mass is defined as the triple integral over the region E, and rho x y z, it is a function of x y z, it is the density function given with respect to dx dy dz. So, this is the mass formula. Similarly, the moments about the 3 coordinate planes, the moments about yz plane is defined as the triple integral x into rho density function into dv, and moments about xz plane, it is y into the density function dv, and moments about xy plane, it is z into that. Simply substitute the rho function here, then multiply x y z. You want the moments about any planes, use these formulas to calculate. Then what is center of mass here? The center of mass is a point located at x bar, y bar, z bar, where its formulas are x coordinate of the center of mass is m_y_z. m_y_z, we know that it is the moment about the yz plane divided by m, that is the mass. So, this gives the x coordinate of the center of mass. Similarly, y coordinate is mxz, it is the moment about xz plane divided by its mass. Z bar is moment about xy plane divided by mass. So, these are the center of the mass, these are the coordinates of the center of the mass. If the density function is constant, then the center of mass of a solid is called the centroid of the region E. If the density function is a constant function, then this center of mass is nothing but the centroid of the region E. Then other formulas, the moments of inertia about the 3 coordinate planes. This Ix is the moment of inertia about the x axis. So, y square plus z square into rho, it is density function into dv, and similarly Iy, it is the moments of inertia about y axis, that is x square plus z square rho into dv. Moment of inertia about z axis is x square plus y square, rho is given in the problem. So, integrate with respect to dx dy dz. So, these are the formulas for to calculate moments of inertia. Now, another formula is used in electrical subject. So, as in the double integrals, the total electric charge on a solid object occupying the certain region E, having its charge density is sigma, it is a function of xy. So, this formula gives the total electric charge, Q is equal to triple integral sigma xyz dv. So, integrate means using triple integral we can calculate the total electric charge of a solid object. So, this is the formula of that. Now, we take one simple example on applications. The question is, set up an iterated integral to compute the mass of a solid, that is cone, bounded by the equation z is equal to root x square plus y square, and z is equal to 3 is a plane, 3-dimensional plane, if the density function is given rho x y z is equal to z. The problem is to set up the triple integral. Iterated integral means triple integral to compute the mass. We know the mass formula, that is triple integral density into dV. So, this is the given solid figure, that is cone, z is equal to root x square plus y square, represents the surface of the cone it is. So, it is starting from the origin to along z axis. When x and y varies, so z becomes this circle it is. When x y are 0, it is z equal to 0, that is the origin. When x y are increasing, so it traces the cylinder. So, to set up the triple integral limits, first we take the z limits. Z limits are clear here. Z is equal to this surface, cylinder surface, root of x square plus y square 2. The upper limit is given as a plane, z is equal to 3, it is given in the problem. So, from the cylindrical surface to the plane surface, that is the z limits, that is the boundary of this solid. Z is equal to the cylinder, root x square plus y square, and the upper limit, upper surface is the plane, z is equal to 3. So, these are the z limits of the triple integrals. Then after finding the z limits, we go for the other two outer limits, of integration, middle integral and outer integral. So, those limits are obtained from the projection of this. So, your cylinder coincides with z equal to 3 plane. So, it is the equation of the circle, x square plus y square equal to z equal to 3 means it is 9, circle of radius 3. Its projection on the xy plane, we have to take its projection on the xy plane, it is nothing but a circle, x square plus y square is equal to 9. See in this picture. So, the inner integral I told you already, it is z equal to root of x square plus y square to z equal to 3. These are the limits of inner integral. So, cylindrical surface to a plane surface. Then rho density function dx dy dz. So, rho is replaced by z, it is given rho x y z equal to z. Then go for finding the other two limits. The cone intersects the plane, it is given in the problem, z equal to 3. So, taking the projection of that solid on the xy plane, it is a circle in the last figure. So, projection of this solid figure on the xy plane. When z limits are functions of xy, we need to take the projection of the solid on the xy plane only. So, it is a circle, x square plus y square equal to 9. Once we got a circular region in the xy plane, so limits can be found easily. The limits of the middle and outer integrals are obtained from this circle. We know that how to find the limits of the circle. So, x varies from minus 3 to plus 3 and y varies from minus root 9 minus x square to plus root 9 minus x square. This is one way of finding the x limits constant and y limits functions of x. So, other way also it is possible. You want to take y limits constants, again y varies from minus 3 to plus 3, they are constant limits of y, and take x limits are functions of y in that case. So, minus 9 minus y square less than or equal to x less than or equal to square root of 9 minus y square. So, you can take any one of those two types here. Then write down the triple integral formula. So, mass m, its formula is triple integral E is the solid region, that is cone, rho x y z the density function into dV. So, limits we have set up here, minus 3 to plus 3, these are the x limits, y limits are minus square root of 9 minus x square to 9 minus x square. So, these are the z limits from the cylinder to plane. So, once we set up the limits, then go for integrating z first, then y, then x. So, now integration of z here, only it is the function z, integration of z with respect to z is z square upon 2, then substitute the limit square root of x square plus y square to 3. So upper limit is 3, the lower limit is this. So after substituting, so z is equal to 3 means 3 square, that is 9, 9 upon 2, that is the value of the upper limit. Next, the lower limit, z is equal to root x square plus y square. So it is given here z square, means squaring this, it becomes x square plus y square upon 2. So this completes the evaluation of the integral with respect to z. Now the remaining two integrals with respect to y and with respect to x. This is nothing but the evaluation of the double integral. Now look into the limits of the double integrals. We have discussed in many examples. It is the reason. What is the reason here? Reason is a circle, x square plus y square equal to z square. So instead of simply integrating with respect to y and with respect to x, so it leads to, it is not so simple calculation. So whenever we have the limits of circle, whenever the reason is a circle or part of a circle, it is better to transform, it is better to change the Cartesian to polar coordinates. So we know that the relation between Cartesian to polar, they are x is equal to r cos theta and y equal to r sin theta. And this area element dx dy, that is in the Cartesian, by changing to polar, that becomes r into dr d theta. So r is the Jacobian of xy with respect to r and theta. So dx dy is replaced by r dr d theta. So once you change Cartesian to polar, you also change the limits of xy to r and theta. So it is a circle, x square plus y square is equal to 9 means the radius of the circle is 3. So r is the radius here. R varies from 0 to 3. That covers the entire area of the circle. And what about theta? It is a full circle, one circle, it is a full circle on the xy plane. Theta you can take, theta is 0 to 2 pi, one circle, it is full circle, not the part of the circle. So the projection of this solid is a full circle on the xy plane, so that the theta limits are 0 to 360, 2 pi. So r varies from 0 to 3. So the limits mass formula becomes theta equal to 0 to 2 pi and r equal to 0 to 3, and also change these into r and theta. So 9 by 2 is same. So x square plus y square is replaced by r square, means x equal to r cos theta, y equal to r sin theta. Squaring and adding these two, you know that x square plus y square is equal to r square. So r square divided by 2. So it is changed to polar coordinates. There is no x and y involved here, only r and theta and their limits. Now integrate with respect to r. Here r and theta are independent here. There is no mixture of r and theta equations here. So you can integrate separately with respect to theta. So 0 to 2 pi d theta means it is 2 pi. Integration of d theta is theta using the limits 2 pi minus 0, that is 2 pi. That integration is over. The remaining is r. 0 to 3, integration of 9 by 2 with respect to r, that is 9 by 2 into r. 9 by 2 is a constant, its integration with respect to r is 9 by 2 into r, minus r square integration is r cube upon 3. R square integration is r cube upon 3. So it is r cube upon 6, it is actually r cube upon 6. R square integration is r cube upon 3, 3 into 2, r cube upon 6. So it is, 9 by 2, it is not integration, just multiplied by r here before the integration. 9 by 2 into r, it is 9 by 2 into r. So r square is multiplied by r here, not the integration. R square is multiplied by r, it is r cube upon 2, it is correct, r cube upon 2. Then dr. Now integrate with respect to r. So 9 by 2 constant, r integration is r square by 2. R square by 2 into 2 is 4. So 9 by 4 r square, that is the integration of the first term, minus second term, r cube integration is r raised to 4 divided by 4. R raised to 4 divided by 4, already 2 is there, 4 into 2, 8. So this is the integration with respect to r. Now you substitute in place of r the upper limit 3 and lower limit 0. R equal to 3, 3 square, that is 9, 9 into 9 81, 81 upon 4 is the first term, minus lower limit r equal to 0, it is 0. Next the second term minus r raised to 4, 3 raised to 4, 3 raised to 4 is also 81, 3 raised to 4 is 81 divided by 8, simplifying these two, 81 by 4 and 81 by 8. So, it becomes 81 by 8 again, this 2 cancels. So, 81 by 4 pi, this is the value of the mass using the mass formula. So, mass value is 81 upon 4. So, this completes the evaluation of the mass using the triple integrals. So, we conclude this triple integrals. The limits of the triple integrals, you remember, the limits of the outer integral must be constants. So, whenever you have 3 set of limits, the outer integral limits to be constants only. Then the limits for the middle integral can involve only one variable, that is in the outer integral. When the outer limits are x, so middle integral can involve the one variable x. Then the limits of the inner integral can involve the two variables, those on the outer integrals. So, this help you to set up the limits of triple integrals. So, remember always the limits of the outer integrals to be constants only. We cannot take the variable limits as outer limits. The middle integrals variables involve the function of the outer integral variable. When we have outer limits are, if we take outer limits are y limits are constants, they are the outer limits. The middle one variable is suppose x, it should be a function of the outer integral variable y. Then the inner integral is a function of the two variables which are already defined in the middle integral and outer integral. So, we take care of these points while setting up the triple integrals. This you can make it clear. These are the triple integrals, we call it as this is inner integral, middle integral and outer integrals. So, outer integral limits to be all the time constants. Then the middle integral limits, they are function of one variable, that variable is the variable taken to outer limits, and the inner limits are the functions of the two variables. They can be a function of two variables, which two variables they are set up with the middle integral and outer integrals. So, in this way you define the triple integral limits. Now, that was about the double and triple integrals we have discussed in the earlier sessions. Now, we will move to the beta and the gamma functions. This also included in our multiple integral chapter. So, what are the beta and the gamma functions? So, these are the tools, we can say, tools for evaluating the double integrals. Why they are tools? Why beta and gamma functions? We see many difficulties in evaluating the integrals. For example, to evaluate 0 to infinity e raised to minus x square dx, analytically it is means very difficult to evaluate such integrals, even though minus infinity to plus infinity e raised to minus x square dx not possible to integrate, even infinity to 0. And other example, you see 0 to 90 square root of sin x, it is not possible to evaluate any other known standard integration methods. Even root tan x, it is difficult to evaluate it. See another integral 0 to 1 x to the power 100 and 1 minus x to the power 201 dx. They are very substitution we can use, but they may take lengthier or difficult to evaluate. And also these are useful here to calculate the fractional factorials. We have not studied till today, only the factorials we can find for positive numbers, 1 factorial, 2 factorial, 3 factorial, any positive integer factorial we can find it easily. But what about the 1 by 2, 0.5 factorial is not possible in general. And what about minus 1 by 2 factorial and 3 by 2 factorial, 5 by 2 factorial. So, that any n by 2 factorial we can find using beta and gamma functions. That is why you need to study beta and gamma functions. So, you will get to solve such difficulties in examples. So, what are these beta and gamma functions? We call it as these two are improper definite integrals, which are commonly encountered in many science and engineering problems. These functions are used in evaluating many definite integrals. Suppose the integral a to b fx dx, any integral with the limits a to b fx dx is said to be an improper integral. Means when you call it as improper integral, if the limit, the case 1, limit of a or lower limit or upper limit or both the limits are infinity, lower limit of the integral, definite integral, or upper limit, or both are becomes infinite, in that case the integral is said to be an improper integral. That is one case. Even though the upper and lower limits are finite, a and b are finite limits, but the function becomes infinite for x equal to a or x equal to b or at one or more points in between a and b also. In such cases, the definite integral a to b fx dx is said to be an improper integral. Now, coming to what is a beta function. Beta function is denoted by the symbol beta in the bracket m comma n, or we can refer capital B m comma n is defined as it is an integral 0 to 1 x to the power m minus 1 and 1 minus x to the power n minus 1 dx, where m and n are positive numbers here. So, m, see here, first argument in the bracket that corresponds to exactly x to the power that number minus 1. Second argument corresponds to 1 minus x to the power n minus 1. This n corresponds to here, and this x to the power m corresponds to beta m. So, this is the definition of beta mn. So, what are the properties? Before going to the examples, we need to study the properties. They are useful in solving the examples. So, one of the properties is the symmetric property. Beta mn and beta nm, they are same, symmetric property. If you replace m and n, or if you interchange m and n, beta mn is equal to beta nm. So, we can prove that property by definition of beta mn. By definition of beta mn, it is 0 to 1 x to the power m minus 1 and 1 minus x to the power n minus 1 dx is the definition given above here. Now, using one of the definite integral property, everyone knows that 0 to a fx dx is equal to 0 to a f of a minus x. A is the limit of integral, f of a minus x dx. This is the property of one of the property of definite integral. So, using this property in the above definition, means here a is 1, here the property says 0 to a in the definition of beta mn 0 to 1. So, a is 1. So, this integral is, you consider fx is this x to the power m minus 1, 1 minus x to the power n minus 1, that is fx. So, 0 to 1 f of 1 minus x, f of 1 minus x using the property. So, in place of x you substitute 1 minus x here. So, you can substitute here f of 1 minus x, beta mn is equal to, you can see on the board, beta mn by the definition 0 to 1 x to the power m minus 1, 1 minus x to the power n minus 1 dx. That is the definition. The property says that 0 to a any function fx dx is written as 0 to a f of a minus x dx. So, that is the definite integral property. I am using this property in the above 0 to 1. So, a is 1 here. So, replace 1 minus x, f of 1 minus x. So, in x in place we replacing x by 1 minus x, m minus 1, and second term 1 minus x is replaced by 1 minus x raised to n minus 1 dx. So, applying the property, it simplifies to 0 to 1. I simplify this bracket term, 1 cancels, minus minus plus. So, it is x to the power n minus 1, 1 minus x to the power m minus 1 dx. So, this we can say that beta nm, n is x to the power number, m is 1 minus x to the power number. So, how m is x to the power number, n is 1 minus x to the power number. So, beta mn is nothing but beta n comma m, x to the power, that is the first value in the bracket, and m is the power of 1 minus x. So, this is the property beta mn equal to beta nm. Coming to another property, that is trigonometric form of beta function. So, this beta mn we can express into this integral. Again, by the definition of beta function, beta mn is equal to 0 to 1 x to the power m minus 1, 1 minus x to the power n minus 1 is the definition. Now, I substitute x is equal to sin square theta in the definition, x is equal to sin square theta. See that dx is equal to, differentiating x here, 2 into sin theta differentiation cos theta d theta. So, dx becomes 2 into sin theta into cos theta into d theta. So, while substituting x to theta, you also see the limits of theta here. When x equal to 0, see what is the value of theta. When x equal to 0, sin square theta equal to 0 means theta is equal to 0. So, when x equal to 0, theta also 0, and when x equal to upper limit, x equal to 1 you substitute here, x equal to 1, sin square theta is equal to 1 and sin theta is equal to 1. So, when sin theta is 1, that is theta is equal to 90. So, sin 90 is 1, that is why theta is 90. So, we have changed the limits of integration 0 to 1 to 0 to 90. Therefore, the above definition beta mn is 0 to 1 x to the power m minus 1, 1 minus x to the power n minus 1 dx is converted to 0 to 90 theta values. So, in place of x you substitute x is equal to sin square theta as it is substituted, power m minus 1 it is there, and 1 minus sin square theta, 1 minus x is 1 minus sin square theta to the power n minus 1, and also replace the dx value, dx is 2 sin theta into cos theta d theta. Now, simplify this, you can see here what is the sin to the power, sin theta to the power is 2m minus 2, and 1 minus sin square we know that it is cos square theta. Cos square theta means cos theta raised to 2 into n minus 1. So, cos raised to 2n minus 2 and 2 into sin raised to 1 and cos raised to 1. Combining these, we get the same thing is written here. See that sin raised to 2m minus 1 2 theta, cos raised to 2n minus 2 theta, this as it is 2 sin theta into cos theta. So, collecting the powers of sin and cosine, here sin power is 1, cos power is 1, collecting with this we get beta mn is equal to 2 is a constant taken outside, sin to the power 2m minus 1 theta, 2m minus 2 into sin theta means adding the power 1, 2m minus 1 theta. Similarly, cos raised to 2n minus 2 plus 1, that is cos raised to 2n minus 1 theta d theta. So, beta mn is can also be written as 2 times of this, or changing theta is a dummy variable here, changing theta to x here, it becomes beta mn is equal to 2 into sin 2 into integral 0 to pi by 2 sin 2m minus 1 x cos raised to 2n minus 1 x dx. This form is known as trigonometric form of beta mn. From the definition of 0 to 1, this is another property. Coming to another formula, you can call it as a property. So, that can be obtained using the previous result. 0 to pi by 2 sin raised to p theta cos raised to q theta d theta is equal to expressed in terms of beta function. Now, putting 2m minus 1, we have the previous result 2 here property, putting 2m minus 1 is equal to p and 2n it is, 2n minus 1 is equal to q, not m, it is 2n minus 1 is equal to q in the above result. So that simplify m is equal to 2m is equal to p plus 1. So, m is equal to p plus 1 upon 2 and similarly n is equal to q plus 1 upon 2 using in the property 2. Now, this becomes the same beta mn, replace m is equal to p plus 1 upon 2, p plus 1 upon 2 and n is equal to q plus 1 upon 2. So, this p 2m minus 1 is p. So, sin raised to p theta cos raised to q theta d theta is equal to. So, 2 is on the right hand side, you take it along with the beta mn. So, this is the result. So, this formula is particularly useful in evaluating sin raised to p and cos raised to q theta whenever the limits are 0 to pi by 2. So, this type you studied in the reduction formula, the problems on the reduction formula. Those examples can be solved using this beta gamma beta function. So, refer here, directly substituting p value, p may be any number, substitute here, then evaluate it. There is another property beta mn is equal to 0 to infinity x to the power m minus 1, 1 plus x to the power m plus n dx. To prove this, we need a substitution here. We need a substitution. By the definition of beta mn, we know that put x is equal to 1 upon 1 plus y. We can prove here this problem. Beta mn, we have to prove that 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m plus n dx. To prove this, from the definition of beta mn, we know that this is the basic definition of beta mn, 0 to 1 x to the power m minus 1, 1 minus x to the power n minus 1 dx. To prove the result, the substitution is x is equal to 1 divided by 1 plus y. Substituting x is equal to 1 divided by 1 plus y. Then calculate dx and limits of y also. Dx is equal to differentiating this with respect to differentiating this, x is equal to 1 divided by 1 plus y. So, differentiation of this is minus 1 divided by 1 plus y whole square. How 1 upon y is minus 1 upon y square? This is 1 plus y whole square dx. So, that is the differentiation of the given equation. And also see the limits of whenever x equal to 0, what is y? You can simplify this, x into 1 plus y is equal to 1, cross multiplying, or x plus xy is equal to 1. I write xy is equal to 1 minus x, so that y you can write y is equal to 1 minus x upon x. What I have done is, from x is given in terms of y, I have converted y in terms of x from this equation. So, you can find limits easily. When x equal to 0, so it is 1, y is equal to 1. And when x equal to the upper limit 1, x equal to 1, 1 minus 1, 0 divided by 1, so y equal to 0. X equal to 0, you see that x equal to 0, denominator 0, it is not 1, denominator 0, it is infinity. X equal to 0, it is 1 minus 0 divided by 0, 1 by 0 is infinity. So, 0 to 1 is converted to infinity to 0. Therefore, the above beta mn is 0 to 1, 0 to 1 is converted to infinity to 0, 0 to 1 is converted to infinity to 0, and x is equal to, substitute 1 divided by 1 plus y, this is x to the power m minus 1, and 1 minus x, 1 minus 1 upon 1 plus y to the power n minus 1, and then substitute dx is minus 1 upon 1 plus y whole square dy. So, everything is converted into y. Now, simplify what is the y power and 1 y power and 1 plus y power. So, I can interchange the limits. There is a property of definite integrals. We can interchange the upper limit to lower and lower limit to upper limit. For that, we multiply the minus sign. So, I am removing the minus sign, means multiplying the minus sign to the entire integral. So, that changes the limits of integration. That is why I am removing the negative sign, changing the limits of integration. So, it is denominator 1 plus y raised to m minus 1. Simplify this expression, 1 plus y minus 1, that is y divided by 1 plus y. So, means y raised to n minus 1, 1 plus y raised to n minus 1, and this is 1 upon 1 plus y raised to square dy. Now, simplifying this, y to the power n minus 1, that is equal to integral 0 to infinity y to the power n minus 1, and see the 1 plus y to the powers. So, 1 plus y, there are 3 terms here, adding the powers of them, m minus 1, n minus 1, that is m plus n minus 2, adding the powers of base is same, 1 plus y, m plus n minus 2, then plus 2, that becomes m plus n. So, it is 1 plus y raised to m plus n dy. So, this we can call it as beta mn is equal to 0 to infinity x to the power m minus 1, 1 plus x to the power m plus n. So, I can change the variable y to x, 0 to infinity x to the power n minus 1, 1 minus x to the power m plus n, dy is dx. It is not exactly as it is given here, m minus 1. So, beta mn, there is a property, beta mn is equal to beta nm. Using the property, beta mn is equal to beta nm, means we can interchange m and n, nothing change in the denominator. If you interchange m and n in the denominator, m plus n becomes m plus n only. The numerator n minus 1 becomes m minus 1. Therefore, beta mn is 0 to infinity x to the power m minus 1, 1 plus x to the power m plus n dx. So, that is the property. This example is, this property is proved. So, any beta mn is nothing but 0 to infinity x to the power m minus 1, 1 plus x to the power m plus n. Now, we will see the examples on beta function, means any integral we ask you to find, express the integrals into beta function. See one of the example, express 0 to 1 integral from 0 to 1 x dx square root of 1 minus x raised to 5. So, problem is express this integral into beta function, means we identify what is m and what is n in this integral. To identify m and n, this integral function to be expressed in terms of x to the power m minus 1 type and 1 minus x to the power n minus 1. So, convert this integral into the beta integral. You must be knowing the beta integral, beta definition formula, beta definition is 0 to 1, the limits are same, and x to the power m minus 1 into 1 minus x to the power n minus 1. So, express by substituting the suitable x value. So, what is the x value substitution is, see the one of the term we required 1 minus x type, nothing to worry about the power of 1 minus x. So, 1 minus x to the power 5 is there here. we convert this into 1 minus x type. So, for that we need to substitute x raised to phi is equal to some other variable here. So, putting x raised to phi is equal to y, that becomes 1 minus y, right. Then what is x? X raised to phi is equal to y means x is equal to y to the power 1 by 5, taking 1 by 5 power both the sides. So, x is equal to y to the power 1 by 5, then differentiate that. Dx is equal to, we know the differentiation of the power 1 by 5, that is n into x y raised to n minus 1 type it is. Dx is equal to 1 upon 5 y to the power 1 by 5 minus 1. 1 by 5 minus 1 is minus 4 by 5. 1 by 5 minus 1 is minus 4 by 5. So, dx is 1 by 5 into y raised to minus 4 by 5 dy. And see the limits of the integration. Limits are same here. You can check here how they are same. When x equal to 0, that is lower limit, when x equal to 0, y also 0, you can see here. X equal to 0, y is 0. And x equal to upper limit, x is equal to 1, 1 raised to 5 is 1, so y is equal to 1. So, the limits of integration are same here. So, 0 to 1, the given integral x dx divided by root of 1 minus x raised to 5 is simplified to 0 to 1. So, x value is replaced here, x value is y to the power 1 by 5, this is x value. And what about dx? Dx is replaced by 1 upon 5 y to the power minus 4 upon 5 dy, and the denominator square root is there, 1 minus x to the power 5, that is 1 minus y. Now, simplify this. 1 by 5 is a constant, is taken outside, 0 to 1. Simplify y powers. Y power is 1 by 5 and minus 4 by 5. Adding these two, y power 1 by 5 minus 4 by 5, it is minus 3 by 5, minus 3 by 5. And what is the power of 1 minus y? In the denominator, 1 minus y power is half. Remove the square root here. 1 minus y to the power 1 by 2. So, that is in the numerator, it is minus 1 by 2. So, this is coming to closer to our definition of beta function. Beta function is x to the power m minus 1, 1 minus x to the power n minus 1. So, it is closer to the beta definition. Still you convert this power, this number y to the power some number minus 1, minus 3 by 5, you write in terms of a number minus 1. For that, how to write? Minus 3 by 5, add 1 and subtract 1. Minus 3 by 5, adding 1, it becomes minus 3 by 5 plus 1 is minus 3 by 5 plus 1 is minus 3 by 5 plus 1 is 2 by 5 it is. You write minus 3 by 5 is 2 by 5 minus 1. Then 1 minus y to the power minus 1 by 2 is there. Minus 1 by 2 we can write 1 by 2 minus 1. 1 by 2 minus 1. This we can simplify here. One by 5, 0 to 1, y raised to minus 3 by 5, 1 minus y raised to minus 1 by 2 dy. Up to this it is there. Our standard beta gamma function is y to the power m minus 1. From this, what is m minus 1? You have to write 1 by 5, 0 to 1. To write in the form m minus 1, so add 1 and subtract 1. So, minus 3 by 5 plus 1, it is 5 minus 3, 2 by 5. So, y raised to 2 by 5 minus 1. The same value minus 3 by 5 is expressed in the standard form. Standard form is n minus 1 type it is. So, 2 by 5 minus 1 is nothing but minus 3 by 5. Similar way, power of this minus 1 by 2 add 1 and subtract 1. So minus 1 by 2, adding 1 becomes 1 by 2 it is. So it is power 1 by 2 minus 1. So minus half can be written as 1 by 2 minus 1. These are the m and n. dy is there. So that is written as in terms of beta. Beta of m. What is m? This is y power m minus 1. This is m 2 by 5. What is n? It is 1 minus y power 1 by 2. So in this way the integral is expressed into a beta function. See another example similar to that. 0 to 2, 8 minus x cube raised to minus 1 by 3. Express this problem into a beta function. So what to do is convert 8 minus x cube into 1 minus y. So to substitute that 8 minus x cube converting into 1 minus y. Put x cube is equal to 8y. So that becomes 8 minus 8y becomes 8 is common 1 minus y. So in this way you substitute the value of x. So that reduces to 8 minus 8y. Then dx x cube equal to 8y. X is equal to 8y to the power 1 by 3. Dx is differentiation becomes this. So the given integral is converted to 8 minus 8y to the power minus 1 by 3 it is there. And dx is substituted 2 by 3 y raised to minus 2 by 3 dy. Then 1 by 3 here, 8 is common here, 8 is common, 8 raised to minus 1 by 3. What is 8 raised to minus 1 by 3? 8 is nothing but 2 raised to 3, raised to minus 1 by 3 is 2 raised to minus 1, that is 1 by 2. 8 raised to minus 1 by 3 is 1 by 2. So 1 by 2 means this 2 cancels, that simplifies to 1 upon 3, 1 minus y to the power minus 1 by 3, y to the power minus 2 by 3 it is there. Again this is expressed into a standard form. So minus 1 by 3 is written as adding 1 and subtracting 1. Minus 1 by 3 is plus 1 is minus 1 by 3 plus 1. It is 2 by 3. 2 by 3. It is not as it is here. Minus 1 by 3 plus 1. It is 2 by 3. 2 by 3 minus 1. So m value is 2 by 3. And then minus 2 by 3 is written as adding 1 here. It is 1 by 3. 1 by 3 minus 1 is minus 2 by 3. And 2 by 3 minus 1 is minus 1 by 3. So it is 1 upon 3 into, it is beta of 2 by 3 comma 1 by 3. Beta of 2 by 3 comma 1 by 3. So in this way we convert every integral into a beta function. Looking into the definition of beta function, we substitute the value of x. So we will conclude today's session with this problem. Thank you.